Greetings, Integrated 3 students. Hello, this is Dylan, your math teacher from across town, bringing you what is hopefully going to be a video that makes sense and helps you with the math problems for quarter 4 and the assignments we have for the rest of the year. When we last left our heroes, you were right in the middle of the first of 2 weeks of mandated state and national testing. This is unbelievable. We spent over a month preparing for the test. We went over every practice problem of both types of tests. The first week was going so well, you were trying so hard. And then, boom! Not only is the test stopped right in the middle, we're not going to get a chance to finish it. We just learned we're out for the entire rest of the year. Therefore, you're not going to have to take the test. It's not going to matter, but what a weird way to end the year for us. Thank you so much for all the time you did trying to take those tests. So many of you guys are upperclassmen. Some of you are seniors. We're trying very hard to make sure that you have all that you need to graduate. The state of Oregon is coming out with a number of guidelines where if you were a graduate at the time that we went on break, if you were passing for quarter 3, there's potential for you to pass quarter 4 as well. So anyway, I don't know how many of you are going to see this video, how many of you are going to be in this class, but for those of you who are, welcome. This is going to be a lot different, as you know. Instead of being in front of you lecturing twice a week, I'm going to be recording these videos for you. Now, the entire next month of class was scheduled to be work samples to meet our what's called the essential skills requirement to be able to graduate high school. And that's for those of you who did not end up passing your test. Well, as I said, we didn't even get to finish the test. Therefore, the whole thing's thrown out. That includes the next month of curriculum. We cannot do these remotely. So, I'm scrambling here a little bit with this class. And what that means is that I'm just going to give you one assignment a week right now. That's not just because you're upperclassmen who have a lot of things going on. That's because a lot of you are seniors who end up maybe not going to need to take this class. Others of you are going to focus on other classes like making sure that your senior English classes are good to go. These are uncertain times, and how I'm going to fill this is basically having a few assignments that are going to be useful for you when you graduate high school after we get through the little bit of curriculum that we had left that I was already planning on doing before all this happened. And that starts with today on a lesson called Exponents and Roots. So, Integrated 3, you see on the left, you should hopefully be logged in. You should see your name in the top right. Scroll down, you'll pass topics 1, 2, 3, and you'll get to 4. Now, when you end up seeing this, you will only see one assignment that's available in blue for topic 4, and it's this Exponents and Roots number 1. Now notice, I went through every single one of these assignments, and I added where you can find it in the wider website. So just like I showed for my Integrated 2 class, we have my courses up here. And in addition to our Integrated 1, 2, and 3, we have all these other classes that maybe you've never seen before or haven't paid attention. Each one of these are units that other schools around the whole country right now are using for their online curriculum. And we're the only ones that very luckily have this custom curriculum that we can use that we've built for the last 8 years. But we still take our PowerPoints and notes from all these other classes. So that's where you can find them, even if the links are broken, but they shouldn't be right now because I went through and made sure all of them are active and working. So you can click, for instance, on this notes in PowerPoint, and it will show up. Boom! It'll show up the PowerPoint. But you don't necessarily even need that because you've got something better than PowerPoint. You have me teaching you how to go over each one of these problems. Now you'll also notice I have opened what I recommend you doing, which is a new window with not our, sadly, perfect TI-84 yellow graphing calculators. Those are stuck in our classroom. They're going to be there indefinitely. I miss them. You miss them. We had so many that looked so cool with SpongeBob designs and other wonderful art projects from students. Instead, we're going to use Desmos. And specifically for this lesson today, you're going to need to know, and you could get there by hitting this little keyboard button, where the square root button is. So that's right there. You can type in any square root. But also where the cubed root is. So it's a little annoying because you can't just stick a 3 in front to get a cubed root. Instead, that's going to give you 3 times the square root of 64, which is why it's 24. Instead, you need to hit, let me use my little arrow feature here. You need to hit this functions button right there. When you hit the function button, you then go to miscellaneous, and it is hiding right here. And again, you could pause this video right now, and you could go into Desmos, and you could try this out for yourself, and then you can hit play. The beauty of this is going to be you can go at your own pace. If you're spacing out, looking out of the window on this gorgeous Oregon day, then you can rewind it until when I give this direction again. You're in control of Digital Dylan, math teacher, which is such a great place to be. I'm going to click on that button, and I'm going to do it in its own section. So right here. And now you could take the cubed root of 64, which you'll notice is in fact different than the square root of 64. Cubed root is what number times itself again is 64. 4 times 4 times 4 is indeed 64. And the square root of 64, what number times itself is 64? That's 8, because 8 times 8 is 64. All right, so have open these two different spaces, and what's cool about this is that you can just leave this and replace the numbers with whatever whole number you really want to. We're not going to have any decimals to type in here, and in fact, for this first assignment, you're not even going to get any decimal answers. All right, that's enough about Desmos. Let's dive into the assignment. Exponents and roots, number 1. Here we go. All right, you can see on the left here we have 10 problems. I'm going to write out all of the work, and then you follow along. A reminder that you have similar questions for each of these, but not the exact answers. So don't just copy from me. If you do, you're going to have to redo the question because it's not going to be right. Instead, apply what I do to the numbers in your problem. Okay. Number 1, enter and answer answers that correctly fill in the blank. Find the real solutions of the equation. Write exact, simplified solutions. If multiple solutions exist, separate them with commas. X squared equals 81, so x equals blank. Each one of these problems is going to be an algebra problem. Now, for those of you out there, either in my class or if you're watching this out in the internet world somewhere, you might remember the old saying, please excuse my dear Aunt Sally, or however else you learned to memorize Pemdas, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. That is the order of operations that you do equations from left to right, where it's parentheses first, then exponents, then you multiply and divide, and finally you add and subtract. Well, what I say often when I teach algebra, and if you're out there doing algebra for yourself, either in my class or another class, or just because you're so bored that you would rather go back and do some algebra from your middle and high school years, I say go backwards. Since with algebra you're often working backwards, that means that we end up writing backwards PEMDAS. And as I tell students a lot of the times, we rarely are working with parentheses, including on this assignment. So it's not sad MEP. It ends up becoming the most kind of a teenage emo phase acronym of all time. Sad me. Oh. Poor cartoon character here. Sad me. As always, I apologize for my drawings and my audio issues. Doing the best I can. All right, that means that we need to first subtract and add, then divide and multiply, and then do our exponents. We're going to have some problems where we do all 3 steps in order to solve our algebra problem. For this one, though, we very simply just have an exponent. X squared equals 81. So what can I plug in for x that when I square it, I get 81? Well, I'm going to clear this to be able to go back to my calculator. Again, you could pause it if you need to stare at this more. If you're taking notes, write it down. What number can I square or multiply by itself? That's another way of saying that. And get 81. Well, I'm going to work backwards, and I'm going to take the square root so it'll answer that question for me. The square root of 81, maybe you knew this off the top of your head. If you did, congratulations. You remember some good mental math. Is 9. 9 times 9 is 81. Now, it says, if multiple solutions exist, separate them with commas. And the reason it says that is because 9 is not the only integer, or not the only whole number, that when multiplied by itself gives you 81. In fact, if I multiply negative 9 times negative 9, you'll notice that is also 81. And it turns out that's true for every even exponent that you'll ever work with. So anytime you see x squared, you could think of this 2 as meaning two different solutions. Your positive whole number and your negative whole number. And when you do that, you will get a nice green response that says, well, for me it says perfect. For you it might say something else. And you'll see it filled in up top, meaning we are done with number 1. So if you ever see an x to the 4th power, not on this assignment, but you would be doing the 4th root and you'd have 2 answers, x6, 8, any even exponent, you'll have 2 answers. All right, that is to be contrasted with number 2. Now we have x to the 3rd power. We have an odd exponent. So for that, we need to use the cubed root button. So go back over to your Desmos calculator to where you have hopefully already preloaded the cubed root up here. And I'm going to replace it with negative 512 because that is the number I have on my right side. And when I do that, you'll see I get negative 8. Now you might be saying, just off the same logic as number 1, what about positive 8? Do I put both answers? Well, no, because 3, our exponent, is not even. And what that means is that if I in fact do 8 times 8 times 8, well, 3 positive numbers times each other is indeed a positive number. It's not going to ever give us that negative 512, meaning we don't put positive 8. We just put our negative answer. And that will also be true for every single x to the 3rd power problem and every odd exponent that you'll ever see. But on this assignment, you'll just see x squareds and x cubes. Okay. Congratulations when you get that one done. You're done with 1 and 2. Now we look at number 3, and this is the first time that we're really going to have to go back to our acronym, our emo-centered sad me, which again I'll write up here, sad me. And remember, we have to first add and subtract, or subtract and add. Well, that's very relevant for this problem because we have subtraction. I say another thing about algebra that I teach all my students. I grew up as a triplet. I know the value of treating 2 siblings equally. My brothers and I used to count the exact number of goldfish, true story, every single cracker that we were given because we were so competitive and so paranoid about being shafted by our mom when we were given food that we had to make sure that we were given the exact same amount. And if it was off by even 1 cracker, which meant that a brother could come in and eat somebody's 1 cracker and then just start a war because it would be on. In the same way, each of your 2 sides of an algebra problem, your left and your right side, notice I separated it with this long line, are like 2 equal siblings. And you always, always, always want to give them the same amount. Whatever you do to one, do to the other. Because if you don't, like my brothers and I growing up, it is going to be a war. And we're not here for any more war. Especially at this time in history, we want to try to produce more positive than negative. Okay. So having said that, we've got our 2 sides of our equation, and we need to do the opposite. So on the left, I know I have to start with subtracting and adding. I'm subtracting 40. So I have to say, what's the opposite of subtracting 40? Well, I can look at my little grouping here. The opposite of subtracting goes with adding. So I'm therefore going to add 40 to each side. Cancels on the left. And now on the left side, I just have my x squared. And my right side, I've got negative 15 plus 40 is 25. And you could use your calculator for that, or you can just do it in your head. You can also use your phone as a calculator for that. Now I need to do what I did for number 1, which is I need to take the square root because we have subtracted and add. We have no division and multiplication, so now we just have exponents to do. Square root of 25. What number times itself is 25? I can either put that in my Desmos calculator. I do not need to, though, because I know in my head the square root of 25 is 5. So I'm going to put 5, comma, negative 5. And if you need to use the calculator for that, you can just replace it under the line with no 3, the square root, not the cubed root. And you'll see, sure enough, 5. Awesome. Number 4. Now we have a number, in this case it's negative, that's attached to my letter. There's no addition sign in between them. There's no subtraction sign. So we are not adding or subtracting. Sad me. We are not subtracting and adding on this problem. Instead, we're dividing and multiplying. And I say, okay, does it mean to divide and multiply when I've got this set up right here? Well, just like I tell students, another thing, when you see this situation, I always try and think of it like you have a bunch of pet rabbits and you leave them in the same cage. Oh my gosh, what's going to happen with all these rabbits? They are going to be multiplying. They are too close together. There's no space. There's no addition. There's no subtraction. There's just multiplying. And so anytime you see a number, even if it's negative, connected to a letter like this negative 3x squared, know that you are multiplying. And so what's right next to multiplication? It is division. So I'm going to go backwards now. I'm going to draw my line to separate my siblings. And I'm going to divide both sides by negative 3. When I do that, my left side cancels. I get stuck with just x squared again on the left. And on my right, negative 243 divided by negative 3. I will show you that. I'm going to have to close out of this. One of the sad parts of this whole thing is I have to close out of the writing, but you can go back and pause it. Negative 243. Divided, I can either use the division sign right there, or I can use the button next to your right shift key. And you'll see it's negative 81. Well, that's because I didn't use negative 3. I got to add the negative 3 there. If I do negative divided by negative, I'll get a positive. And now I can take the square root, because it's got the 2 up here. The square root of 81. I had this up here a little while ago. It is what it was before, 9. Because it's a square root, it's got that 2. It's going to have 2 answers, 9, comma, negative 9. And remember, as you go through this throughout, if you're following along on your own assignment, don't use my numbers. Use your numbers. You're going to have a different problem, most likely. Number 5 is going to be fast because it's completely the opposite of what we just did. We have a problem that is dividing. We have no addition or subtraction. We just have a division and an exponent. So we're going to do the opposite of what we just did. Instead of dividing by both sides, we are going to multiply. That means that cancels. We get x squared on the left. And on the right, 50 times 2 is 100. Now I can take the square root of both sides. Square root of 100, what number times itself is 100? I will skip that step in my calculator because I know that 10 times 10 is 100. And again, I'm going to put 10 and negative 10 because it's a 2 for 2 answers. All right, halfway done. A lot of this has been front-loaded explanation, so we can go a little faster on these last 4. Now I'm adding, so I'm going to do the opposite and subtract. There's a 3 on this one, so I'm going to make sure to do the cubed root of negative 729. That one I will show you in the calculator. So I've got the cubed root of negative 729. It's a 3, so I'm just going to put one answer of negative 9. And just like you're using your own numbers, also use the opposite of what's happening in your problem. If you have a minus 5 here instead of a plus 5, do the opposite of that. So you would add instead of subtract. You're just going to be doing the opposite of every single one of these operations. All right. We are almost done. It's got a few problems left. This is another rabbit problem. These are touching on the left, so I'm going to divide. 1458 divided by 2. That's x cubed is 729. Hey, I just had the cubed root of negative 729, and I saw that was negative 9. So that means the cubed root of positive 729 is going to give me positive 9. Yay! Again, go as slow as you want. Pause, catch up, fly through it if you're going even faster, and then come back if you need the explanation. Work at your own pace. That's the beauty of this. Same thing for 8, and then we'll finally get 2 of them on 9 and 10 that use all 3 steps. Times 2 times 2 cancels. X cubed is 216. The cubed root of 216. I haven't seen that one yet, so I'm going to show you on the right here. Cubed root of 216. Do you have a guess out there? Can you do it in your head? What number times itself is 216? Did you say 6? If so, you're right. And remember, we don't need negative 6 because it is an odd exponent. All right, we're at the 21-minute mark now. Let's finish this up in the next couple minutes. I want to keep these videos somewhere between 20 and 25 minutes. I think my integrated 2 one ended up being about 23, so that's what we need to look at. For the last time today, I'm going to write my EMO acronym. Sad me, because we are about to use all 3 steps of it. We now have a problem that has 3 different parts. It has a number either in front that's being multiplied. It has a number on bottom that's being divided. It has a plus, or in this case for both of mine, it has a minus. We're going to follow these directions here by first subtracting and adding, then dividing and multiplying, and then finally doing our exponents. We're going to treat both kids the same, and we're going to do it backwards, just like we've been doing the whole time. So subtracting and adding is the first thing I look to my problem to see what's happening. I am subtracting 14, so I do the opposite. I am going to add 14 to both sides. You can write this out by hand. I really recommend it as you're following along. That would give me 54, which I could use my calculator for, but I don't need it. Then I'm going to divide. So this is step 1. This is step 2, and this is step 3. That leaves me with x squared on my left, and 54 divided by 6 is 9 on my right. Now I can take the square root of both sides. Square root of 9 is 3, so I've got 3 comma negative 3. And I'm going to leave this since it's up the whole time. I'm just going to do number 10 at the same time. X squared, let's see. I'll just write it. I'll write it right here. X squared minus 8 after being divided by 9 is 1. All right, step 1. Got to do that addition to both sides. I get left with x squared over 9. That equals 1 plus 8 is 9. Then I multiply. This is always pretty funny when it's the same number, because you have to ask yourself for step 3, what number times itself is 81? Let me look approximately 2 millimeters above this to the number that I just literally wrote times itself is 81. The square root of 81, it's come up a lot. It's 9. So my answer on number 10 is 9 comma negative 9. Ooh, and a fun relationship between my answers on 9 and 10. I've got a number here, and I've got its own square root. Cool. Math connections. Ooh, a fun math connection while we've been away is that I turned 32 years old recently on the exact same day that my wife turned 32 weeks pregnant. Is that amazing? The exact same day. It'd be crazy enough if it was the same week, but the same day? That's just mind-blowing in terms of the math that goes behind that. So I'm going to cancel this. I'm going to type in my 3, negative 3. And I'm going to type in my 9 comma negative 9. We are so close to the 25-minute mark, so I want to get out of here and try and keep to that. As I submit this, which you can do at the same time to see that beautiful, hopefully 100 on your assignment, know that I miss you all. I wish you the best and hope that you're safe and well and healthy. This has been a great experiment. Will continue to be class away from class. Goodbye for now.